What do this banana and the Milky Way have in common? The answer might surprise you. Antimatter is somewhat like matter's evil twin. Every particle has an antimatter counterpart with the same mass, but opposite quantum properties, like charge and spin. When matter and antimatter meet, they annihilate, transforming into pure energy which we can observe in the form of gamma rays. Your fruit bowl contains its own antimatter source. Bananas contain a large amount of potassium, and a fraction of potassium atoms are radioactive. These radioactive atoms can decay, and when they do so, they emit an anti-electron, or positron. So, should you be worried about your daily banana? Well, the level of radiation produced by an average banana, known by scientists as the banana equivalent dose, is a measure of the level of radiation exposure encountered on a daily basis. And to put it simply, it isn't harmful. It would take around 100 million bananas to kill you, and you probably wouldn't be dying of radiation sickness. The antimatter itself shouldn't concern you either. The positron produced inside the banana will encounter an electron almost instantaneously, annihilating before it can escape, so no excuses for dodging your 5 a day. Unlike in your banana, positron annihilation is a big deal in the galaxy, the Milky Way. Here, more than 10 to the power of 43 positrons annihilate every single second. That's a 1 with 43 zeros after it. And we know they're annihilating because we can see the gamma rays they emit. We see this using telescopes like the Integral Gamma Ray Satellite Telescope. And the big mystery is, where do they come from? I've spent the last 4 years searching for the origin of these mysterious positrons. One possibility for their origin is that they are produced by a special type of dying star or supernova. These stars begin their lives actually as 2 stars. Eventually, after billions of years, they become white dwarf stars, the burnt-out husks of a star. And these stars spiral closer and closer to one another until they merge in the fraction of a second, creating a supernova explosion. This explosion can produce large quantities of radioactive material, including radioactive titanium. This titanium gets spewed into the interstellar medium by the final explosive death throes of the star. And this titanium eventually decays, ultimately producing positrons, which then go on to annihilate, producing the gamma rays that we observe. I used theoretical calculations, computer simulations, and gamma ray observations to try and better understand where these positrons are coming from and how they travel through interstellar space. So, while antimatter might be a bit bananas, it isn't science fiction, and we're finally getting closer to understanding the great mystery of galactic antimatter.